In the upcoming lab, we're going to investigate heat sinks. To grasp what is happening in the lab that we'll do about heat sinks, you need to first learn 3 things. 1, what a heat sink is. 2, how it works. And 3, where it is used. And that's the purpose of this video, to get you ready for the lab so that you understand heat sinks. To begin, we'll explore what a heat sink is, which will require that we review the 3 types of thermal energy transfer: conduction, convection, and radiation, as well as how each of those types of thermal energy transfer compares and contrasts. Starting with the differences between conduction, convection, and radiation, conduction generally happens through direct contact only. So you have to have a pot touching the stove, or a metal spoon touching the liquid inside a cup or the edge of a cup that's hot. But there's contact, and it's generally between solids. Whereas with convection, you need fluids. So there's some kind of fluid moving, although you could also have a gas moving as well, but generally it happens with fluids. So that's the typical example of a pot of hot water when you're cooking noodles on the stove or rice or whatever. Whereas radiation, no matter is needed at all for radiation to occur because it moves via waves. In terms of speed, conduction generally is the slowest. It takes the longest time for it to happen. Convection happens even faster, but radiation happens the fastest. Conduction, as I mentioned before, is generally solid-based, so you need some solids, whereas convection often happens with fluids, or it can happen with some gases, and radiation happens via waves, as I mentioned as well. Now, 2 of these are a similarity, but there is a difference with the one. With conduction, there's no reflection or refraction taking place, and the same is true of convection, but in radiation, reflection and refraction are factors. Some other similarities as well are that temperature differences drive both conduction and convection, and density plays a role too with convection. You can remember that as a liquid heats up, it becomes less dense and rises to the top, where away from the heat source, it cools down and becomes more dense and sinks down to the bottom again, where the cycle repeats if it gets back to the heat source. So you get this circular movement. And then radiation happens in objects that are greater than 0 degrees Kelvin. Can you think of a situation where all 3 types of heat transfer might occur at the same time? One example is cooking a roast in an oven. Conduction happens where the roasting pan directly touches the food, transferring the heat through direct contact. Convection occurs as hot air circulates inside the oven, evenly distributing heat around the roast, and radiation happens from the oven walls and heating elements as they transfer heat directly to the roast via electromagnetic waves. What are some real-life examples of conduction, convection, and radiation that you see or experience every day, and how do they work? An example of conduction is when you hold a metal spoon in a hot cup of tea. The heat transfers from the liquid to the spoon through direct contact. Boiling water for pasta illustrates convection, as this process of heated water at the bottom rising up to the top when it becomes less dense, and then cooling as it's away from the heat source and becoming more dense and sinking back down is a good example of convection. Radiation happens when you feel the warmth of the sun on your skin, or you stand near a campfire, because the heat is transferred through electromagnetic waves without you needing air or direct contact. Why do you think radiation can happen without matter, while conduction and convection require it? Radiation occurs via electromagnetic waves, which can travel through a vacuum without the need for particles. This is why we can feel the sun's heat on the Earth, even though space is nearly a vacuum. In contrast, conduction and convection rely on particles interacting. Conduction requires direct contact between solids, and convection depends on the movement of fluids or gases. So, what is a heat sink? A heat sink is like a sponge, but instead of soaking up water, it soaks up heat from something that's getting really hot, like a computer, gaming console, or machine. Its job is to pull the heat away and spread it out so the device doesn't overheat or get damaged. Think of it as a superhero for hot things, keeping them safe and working smoothly. And how does a heat sink work? First, it absorbs heat. The heat sink touches the hot part of the device and absorbs the heat, just like a sponge soaking up water. Second, it spreads heat out. It has fins or ridges that spread the heat over a larger area to cool down faster. Third, it lets heat escape. The heat then moves from the fins into the air, helping the device stay cool. Heat sinks are usually made of metal like aluminum or copper because those materials are great at moving heat. They're like a fan for your machine, but instead of blowing air, they pull heat away to keep everything running efficiently. So, how are heat sinks used? What are some applications? One use is in computers. Heat sinks are used inside computers to keep the parts from getting too hot and slowing down. They're likewise used in gaming consoles like PlayStation and Xbox, which use heat sinks to cool down their internal parts so they don't overheat during long gaming sessions. Cell phones use them too. They have small heat sinks to prevent their processors from getting too hot when running apps or games. LED lights use them too. Heat sinks help LED lights cool so that they last longer and don't burn out quickly. And finally, cars are another example. Some parts of a car's engine use heat sinks to help keep the engine from getting too hot while it runs. But that's not all. Passive cooling is super important in machines like fighter jets because it helps them stay cool without needing extra energy or adding heavy parts. Fighter jets need to be very light and fast to do their job, so every bit of weight matters. When we use passive cooling, it means heat can move away from hot parts like engines or electronics naturally, just by using special materials or designs. For example, metal pieces, the heat sinks, can pull heat away and spread it out so it doesn't stay in one place and cause damage. This is valuable for 3 reasons. First, it saves energy. The jet doesn't need extra machines like fans to cool down. This makes it more efficient. Second, it reduces weight. Extra cooling machines would make the jet heavier, slowing it down or using more fuel. And third, it improves safety. Keeping parts cool helps them work better and last longer, which is super important in high pressure situations. So passive cooling helps fighter jets stay fast, efficient, and safe without adding extra weight or complexity. Now you know what heat sinks are, how they work, and why they are so important. Heat sinks are like little superheroes that keep our devices and machines cool by absorbing heat and spreading it out. Whether in computers, gaming consoles, cell phones, LED lights, cars, or even fighter jets, heat sinks make sure everything runs smoothly without overheating. Remember, understanding heat transfer, conduction, convection, and radiation helps us see how heat sinks do their job. So next time you use your phone or play a game, think about the heat sink working hard to keep things cool.